Hi, my name is Adam Smith. I'm an applied climatologist at NOAA's National Centers for Environmental Information and the lead scientist for the U.S. billion-dollar weather and climate disaster product. Today, I would like to highlight a number of our different data resources available to provide a better understanding of disaster costs over space and time, hazard risk and hazard resilience, and how the historical record has changed over time and where the hotspots are for different hazards. To do that, here is a quick outline of what I'll be talking about today. First, we'll provide some context who are our public and private sector data partners and talk about what we're measuring, but also what we're not measuring. I'd like to also highlight the historic year last year we had of these billion-dollar weather and climate disasters across much of the country and put that into historical context with other years and other extreme events. And the second half of the presentation, we'll be looking at the disaster data tools, the maps, the different interface structures we have for you to get at the data and ask different research questions. And finally, I'd like to wrap up with new and future work we're embarking on right now. So NOAA's National Centers for Environmental Information, where I work and where this product is based out of, as you can see, has a broad array of different products and services in regards to weather and climate extremes, but even other topical areas. And you can see, as this chart shows, these products go from daily to weekly, all the way out to annual and to decadal timescales. They also are local, national, or even global. And the billion-dollar disasters, as you can see in the top right, is in relation to insurance, reinsurance, and risk modeling and understanding how extremes impact our economy. So NCEI has been around since 1950, and this product kind of underscores the mission at NCEI, which is the nation's scorekeeper in terms of trends and anomalies of different weather and climate variables and extremes. So this product tries to look at the economic and societal impacts from these really impactful events because we can learn from them and better mitigate our future from what we learn about what happened during the events themselves. Over the last 44 years, as you can see at the bottom of the slide, we've analyzed 376 separate billion-dollar weather and climate disasters in today's dollars. And that does include sub-billion-dollar disasters that are now $1 billion in 2024 dollars. And the cumulative cost is more than $2.66 trillion. So certainly there are different ways you can go about doing this type of analysis. So here's a chart to kind of describe what we're doing in terms of this research. On the left, you'll see different disasters that we look at. So wildfires, tornadoes, floods, droughts and heat waves, snowstorms, winter storms, and of course hurricanes. We don't look at the geophysical events such as earthquakes or tsunamis. There is a part of NOAA that, in NCI that has those products, but this is mostly focused on weather and climate extremes. So in the middle, you'll see, well, what impacts do you want to measure? The best public and private sector data to date resides in the middle. So damage to businesses, homes, public infrastructure, private property. The purple and orange boxes are new areas of research we're working on but are not yet operational. So damage to human health and well-being, and also natural capital and environmental degradation type damages or non-market losses. So we're trying to capture the best public and private sector data that we have available, but no, it's still a conservative approach. Here's a little bit of a deeper dive into that last slide. So we have the 7 core hazard types at the top, as I mentioned before. And on the left side of this, you'll see some key public and private sector partners. So the insurance and reinsurance world, FEMA with their presidential disaster declarations and their national flood insurance program. Also USDA's crop insurance agency. They pay out for many different hazards. The National Interagency Wildfire Center is important, as well as U.S. Army Corps of Engineers, the Energy Information Administration, and state agencies that often do post-disaster reporting. They all provide different context that might not be available in other sources. So the X's denote the partners' intersection of their data with the hazards at the top. And from all these different partners, which are roughly about 12, we're capturing 16 different asset classes noted in the box at the bottom. So that will be total direct losses, which is insured and uninsured damage to homes, businesses, government buildings, all the contents of those structures, even time element losses like business interruption or loss of living quarters. Also damage to vehicles, to boats, to offshore energy platforms, even military bases that are damaged from hurricanes or floods. Public infrastructure is also important to capture, which sometimes the private sector and insurance folks don't really look at because it can be insured by state or federal government. So damage to roads, bridges, levees, electrical grids, which are often a public-private partnership to rebuild after the fact. Lost hydropower out west, often from drought. We also can factor that in. And finally, agricultural and forestry assets, such as damage to crops, livestock, commercial timber, and wildfire fighting suppression costs. So those are roughly the 16 different asset classes. But it's equally important to note what we're not measuring. In the bottom right of the slide, we talk about, as I mentioned, natural capital or environmental degradation. So coral reefs that are damaged, for instance, from a hurricane, that's not an operational input for our analysis yet because there's not quite a framework for that. Or the mental and physical health care related costs. Each state has kind of a different system, the way they track that, and so it makes it too heterogeneous currently to bring it into our analysis. And finally, the downstream ripple effects of supply chain impacts outside of a hazard region. Also, those are not in our analysis. So it's a conservative approach using the best data we have, public and private sector, in the public and private sector, but also it's still conservative because we know we can't measure everything that is damaged. So here's a chart showing 2023, which was a historic year in terms of the count of these billion-dollar disasters. There were 28 separate events that were 1 billion or more in total direct losses based on all these variables I mentioned, from the tragic wildfires in Hawaii to the hurricane Idalia and Typhoon Mawar that hit Guam, to the flooding events from the California floods early in 2023 to the Northeast and Fort Lauderdale flooding across the year. But you can see every year we also have a cluster of the tornado, hail, and high wind events, which really and easily populate above $1 billion across much of the Midwest, the South, and the Southeast. But surprisingly, the most costly event last year was actually the drought. You can see the drought kind of on the border of Texas and Louisiana. That was about a $15 billion event. And for the second year in a row from 2022 and 2023, the Mississippi River was actually very low, and it caused some commerce problems because a lot of that cargo had to be offloaded onto trucks and trains, not on river barges because of the drought. So again, last year, a historic year, but we've had quite a run really since 2017, which you'll see in terms of these billion-dollar disasters. So here's a chart showing just that. Over the last 44 years, from 1980 through 2023, and this is all inflation adjusted to present day dollars, the bars show the count of billion-dollar disasters, color-coded by type at the top, type of event, and the lines show the cost. So the black line is a 5-year running cost average, and the gray and red lines are the annual costs with uncertainty bounds around them. So the 5-year annual cost average, as you see below the chart, is $120.6 billion, which is much higher than the total loss period of about $60 billion per year. Also, over the last 7 complete years from 2017 through 2023, you see the billion-dollar disaster events alone have eclipsed $1 trillion in total direct losses. So these disaster losses are growing faster than population, faster than GDP in some parts of the country, and so we need to learn from these disasters and better enhance our environment so we don't continue to have the impacts from these extremes. Here's a chart showing each of the last 44 years and how the frequency of these events for each of the years accumulated January through December. Again, the black line would be the 44-year average at 8.5 events per year, inflation adjusted. You can see the red line was 2023, head and shoulders above all the other years. And partly that was not just inflation, but that was the addition of how much it was costing consumers to rebuild some of their assets. So it's kind of an enhanced version of inflation, but we also had many events. So you have to think of it in terms of exposure plus our vulnerability, plus for some of these extremes, climate change is amplifying them. This chart is the same setup, but instead of the frequency, it's the cost of these billion-dollar disasters, January through December, each of the last 44 years. Again, the black line would be the 44-year inflation-adjusted cost average at $60.5 billion per year. And last year, even though we had the highest count of events on record, as you saw in the last slide, we were just really in the top 10 in terms of cost because we didn't have one of those catastrophic hurricanes or a really bad wildfire season that can be tens or hundreds of billions of dollars. So the cumulative cost of those 28 events in 2023 was about 93 billion, which is still a very high number, as you can see, relative to the distribution of all the other years and the average. The outlier years you see up top would be 2017, when we had Hurricanes Harvey, Irma, Maria, also the Western wildfire season, and many severe convective storm events. The blue line would be 2005, and that was, again, a hurricane-driven loss exposure with Hurricane Katrina, Wilma, and Rita, I believe, among other events. And even 2022 was another high year at 178.8 billion. So you look at a chart like this and you want to investigate what happened, where did it happen, why did it happen, and try to learn from that to increase your resilience and reduce your vulnerability. But let's look at this more spatially. So for the United States from 1980 through 2023, you can see how the U.S. South, Central, and Southeastern regions have experienced a higher cumulative cost from these billion-dollar disaster events than other parts of the country. In fact, Texas, Louisiana, and Florida really stand out in terms of the top cost for the states from these events, as you can see it to the right. Texas, $402 billion, Florida, $389 billion, and Louisiana, $304 billion. But it's important to note that these costs, of course, are relative to space, to population, to geography. And so the relative costs are actually the most acute in Louisiana because it has losses at the scale of Texas and Florida, but a population and an area and an economic size quite smaller than Texas or Florida. And unfortunately, we are seeing some of the risk management agencies and insurance companies are challenged by trying to manage insurance in places like Louisiana because of just the high frequency of events, which we'll look at. So in 2023, this is a map showing the cumulative cost of the billion-dollar disasters for each of the states. And you can see Texas in 2023 had a $13.8 billion impact. You can see Hawaii is on there, Guam, but much of the central U.S. from the severe convective storm, the tornado, hail, and high wind impacts, and of course California with the flooding. But let's actually look at it on the next slide in terms of GDP. So this slide shows the 2023 billion-dollar disaster cost for each state as a percent of that state's 2023 GDP. And you can see how at the bottom of the map, Hawaii stands out from about 5 to 7.5% of its annual GDP was proportionally wiped out from the wildfire event that happened last year, the tragic wildfire that took over 100 lives as well, and will take many years to recover from. But you can see a number of the other states, Kentucky, Iowa, Oklahoma, Arkansas, had relatively high impacts from these severe convective storm events particularly, and also Vermont, as you see from the flooding that happened in 2023. But let's step it back a few years and I'll make a point about compound disasters with cascading impacts. So that was 2023. Here's 2022. So this was the year Hurricane Ian, which was a $100 billion plus hurricane, made impact in Florida. So Florida did have a big hit from that at exceeding 7.5% of its GDP. And you see a number of other states as well. Let's go that had 2 to 3% of impact for GDP. But let's go back one more year, 2021. So this is one year that Louisiana was really impacted from Hurricane Ida. Hurricane Ida was proportional to 15 to 20% of its GDP. And then go back one more year and you'll see again, Louisiana was in the epicenter from these hurricane impacts and flood impacts. So in 2020, it was Hurricanes Laura, Zeta, and Delta, which cumulatively wiped out about 10 to 12.5% of Louisiana's GDP. You can even see how Iowa, a one-day derecho that raked through Iowa, took out about 5% of Iowa's GDP. That was a really impactful, anomalous event. And so when you have cascading years and cascading disasters that create these damage events that are harder to recover from, it creates a longer recovery period that's more costly and more burdensome, and then people leave the region. You can even see this in the research we did with the Federal Reserve. We looked at a decade's worth of total tax revenue, which is composed of about 25 different variables that varies from state to state. But you can see how Louisiana, for the 2012 through 2021 decade, had more billion-dollar disaster costs than all the different tax revenues for recovery or business tax, etc. And so that just shows another vulnerability and way that these disasters can really impact the bottom line at the state and regional level. So let's zoom back out for a minute and look at the cumulative costs by hazard type for the whole country. And you can look at this for any state, but we'll just look at the whole country for this presentation. So of the 376 separate billion-dollar disasters over the last 44 years, you can see that tropical cyclones, which are hurricanes, strong tropical storm systems, have the lion's share of the losses, 1.3 of the $2.6 trillion, roughly half. And they're also the highest cost per event at $22.2 billion, and unfortunately have the highest fatality count at near 7,000 direct and indirect deaths. And that doesn't surprise people because how impactful, how strong hurricanes are, and how much exposure we have and how much vulnerability we have along our coasts, which is growing year to year. But what does surprise people is the impact of drought. You can see the top line, more than $1/3 of $1 trillion from drought events. And this is largely just to the agricultural sector alone. So this is really a floor of cost and impacts. We also look at the heat component of drought when that has direct and indirect fatalities in the drought affected states. And you can see that drought has the second highest cost per event, only behind hurricane events at $11.4 billion. But finally, I'd also like to point out severe storm events. Again, tornado, hail, high wind, and derecho type events. Almost $500 billion at 455 billion. And that's growing largely from exposure, more concentrated assets and populations. But there is robust research that's looking at tornado clustering and how hail may be shifting in geography over space and time. And of course, Western wildfire seasons have been anomalously bad since 2017. 2017, 2018, 2020, and 2021 were just off the charts for Western wildfires. So a lot of trends kind of going in the wrong direction, but we can learn from these data and try to make other decisions to increase our resilience. Looking at the same data over time horizons of a decade, you can see how the 2010s decade was head and shoulders above the other decades. And again, this is driven from increased exposure, vulnerability, and climate change, of course, amplifying some of these extremes. So we have more and more vulnerable to drought in the West, which is a semi-arid climate, which can lead to longer, more intense wildfire seasons. We've seen that as well. And then in the central and particularly the eastern part of the country, a warmer atmosphere holds more water vapor and therefore can unload more of these billion-dollar flood events. And we had more billion-dollar floods since 2010 than we did in the 1980s, 1990s, and 2000s combined. So that's not just exposure and vulnerability. There's the climate change also factored into that increasing cost. And where we're building, how we're building, that's important for future risk. Here's another chart looking at kind of the climatology of these extremes just for the country. And again, you could look at any state or any region with our data on the website. But you can see really these extremes are kind of a tale of two seasons in terms of what happens traditionally. So in the springtime, March, April, May, we have a lot of flood potential in blue and a lot of severe convective storm events in green. And you can see how those taper off into the fall, where we have a climate which is more driven by drought and wildfire impacts, and of course in the brown and the orange, and hurricane impacts, tropical cyclones in yellow. And you can actually see hurricane season quite well in this chart as it kind of grows through July, August, September into October. And so looking at this in another spatial context, you can see the high frequency of events we've had in really the last decade leads to higher potential for compound disasters with cascading impacts like Louisiana and the hurricanes, or like California, we have a drought having a longer wildfire season, then that flips into the wet season in January, and you have the flood and debris flows. Those are all kind of chained in a tight space-time context where it increases the length of our vulnerability in certain regions for certain hazards. And you can see, again, April, May, June, a lot of that is severe convective storm event potential, where you have clustering of events. And what's kind of striking is in the 1980s, we used to go about 3 months between these billion-dollar disasters. Now we're closer to 3 weeks between these billion-dollar disasters. And, these increasing frequency, diversity, cost, is particularly challenging to the more vulnerable socioeconomic populations that may not have social safety nets like insurance to help them rapidly recover. So I'd like to also switch gears here to talk about how these billion-dollar disasters look in terms of overall risk at the county scale. And this would be a compound risk. This is building on top of FEMA's National Risk Index, but looking at a compound hazard risk. So drought plus flooding plus wildfire events you see are most likely in the western part of the country, or the southwestern part of the country, Arizona, New Mexico, Southern California. And you can zoom in on this data on our website and look at how your county or your area compares to your state, or how your state compares to the country. And it gives a sense for how your cumulative exposure, vulnerability to these different extremes may be in relation to other areas around you. Here's another set of maps showing the combined exposure for tornado plus hail plus high wind events from severe thunderstorm events. And you can see, as we see geographically east of the Rockies, the risk is amplified as the synoptic systems move across the country, and you've got the warm energy and air from the Gulf of Mexico often coming up to collide with the cooler air from the west. And actually, I've got Dallas County, Texas highlighted, and you could click on that and get a lot more data, and I'll give an example. But Dallas County has the highest risk for severe convective storm in terms of its exposure, vulnerability, and just the history of that event over in that area. Also, I think this is an important map to show. People think, oh, hurricanes, I'm 50, 100 miles from the coast, no problem, I'm safe. Well, not exactly. You can see the hurricane risk actually goes quite well inland. This is as hurricanes are becoming extratropical and raining themselves out. It's happened several times in the last several decades. I actually live in western North Carolina, where NCEI is headquartered, and we had, from a tropical storm event that came through the Gulf, almost 2 feet of rain under our house, and it damaged some possessions. And we're 450 miles from where the tropical cyclone made landfall. So you can see, the risk, particularly for rainfall more so than wind, goes well inland. Or Hurricane Ida in 2021, unfortunately, several dozen people were killed from the flooding impacts in New York, New Jersey, and Pennsylvania from Hurricane Ida that came across New Orleans. So, these risks are multifaceted in space and time, and just know your area. Let's zoom in on that last map. Here's the state of North Carolina, as I just mentioned. And you can see, of course, the closer you are to the coast, the higher your risk is, which, of course, makes sense. And in fact, just yesterday, a non-named tropical system that was just evolving dumped about 15 inches of rain where I have in the southeastern corner of the state. And a lot of flooding had happened, and the damage assessments are just happening today. I think loss of life was minimized, but damage to property is, in the recovery phase is just kicking in. So here's a view of North Carolina with a tropical cyclone risk. And again, the darker colors show higher risk. This would be heat and drought risk. This would be, and you can see how the kind of the sand hills where agriculture is prominent in eastern North Carolina have the highest cumulative drought and heat risk. Even wildfire risk. It's not like it is in the West Coast, but the Southeast does have a marginal wildfire risk that can flare up from time to time, and a lot of it is coastal in terms of the risk. And finally, flood risk. You see really North Carolina, the mountains in the west, and then the coastal plain area in the eastern part of the state have higher risk for historical flood damage and impact. And you can click on or zoom in any of these counties or census tracts. But it's also important not to just understand the exposure, vulnerability, and how climate may be enhancing some of these extremes that lead to billion-dollar disasters. It's also important to understand the human component. So we worked with the CDC and the ATSDR, the Social Vulnerability Index they have, which is about 12 different variables looking at core components of society that make society either more vulnerable or more resilient to all sorts of hazards. And so we've integrated this data as well. And I wanted to show these two maps because I think it's important to see how there's a lot of spatial correlation between some variables. For example, in the southeastern United States, you see on the right the percent of the population for each county that lives at the poverty level or below. On the left, you'll see the percentage of homes in each county that are mobile homes. And, unfortunately, there's a lot of course, overlap there. And the issue is, or one issue would be, well, a mobile home is not a great place in a high wind event or a lot of these different extremes. So they need to find shelter perhaps elsewhere to protect themselves. And so these are just different components we've added on top of the physical data itself to give some spatial environmental awareness about what the risk landscape looks like. And finally, this is a study done several years ago, but it was estimating economic damage from climate change in different extremes using a high emission scenario. So it is a high scenario across the United States towards the end of the century, so 60, 70 years from now. And the reason I put this slide up is it kind of shows more of the same, but worse. So in our $1 billion disaster analysis, or in the socioeconomic information I put up in the last few slides, you see the South and the southeastern parts of the country, the counties, have been impacted at a high level in terms of cost, loss of life, the frequency of these events, and maybe socioeconomically, different parts of the region are more vulnerable than other parts of the country. But unfortunately, this also shows that the percent of county GDP, how that may be decreased in the future from the cumulative effects of climate and extremes. And so the spatial relationship of this projected outcome, I think, is important to show. So to wrap things up, what we've done in the last year would be a few of the different items I've just mentioned: the multi-hazard risk, the multi-hazard socioeconomic vulnerability risk mapping as well. We also, I didn't show this, but we have state and regional disaster reports that you can download as PDFs. They're quite thorough. And finally, what we're working on right now that we may actually have available in beta form at the end of this year would be a sub-$1 billion event analysis down to the $100 million level, all the way back to 1980. So over the last 45 years, 1980 to present, we'll be looking at events down a whole order of magnitude in terms of cost and impact. And that may be 600 or 700 new events adding to this database. And finally, we'll be adding some other lenses as far as looking at the data through other ways of analysis to help better understand how it's changed over space and time. So my NOAA email is at the top of the slide. Please feel free to reach out to me, ask me questions, say hello. Also, some links to some of this research is on the slide here as well. And I would be happy to hear from you and take your questions. Thank you.